Yes, good afternoon and welcome to the next panel here on the main stage. We would like to talk a little bit about the increasing densities that we see and the challenges for cooling and infrastructure. And of course, we will bring the topic of liquid cooling into this discussion, even so that we may not see it yet in a broad way distributed here in Europe. I have here on stage Lieke Hammers with Dell, Mike Dulan with CBRE, and Aditya Chalani with Supermicro. So we have two here that actually make IT equipment and bring IT equipment into the data centers. And we have one gentleman that operates, manages, service data centers. So we will take a look at from a lot of different, or at least two different perspectives on the topics that we would like to discuss. And I would like the first question, and I think Aditya that I would like to address to you. If we are talking about liquid cooling, would you consider the total cost to be extremely higher than the traditional air cooling?
Thank you, George, for the question. I think we also get this question pretty often, that liquid cooling costs more, but costs more than what? That is something very important to know. If you're talking about the initial capex, of course liquid cooling will cost more. Consider the investment for the cold plates, CDU, manifolds, etc. But when you look at the total cost of ownership, liquid cooling is much cost lower than the air-cooled solution. We forget to take into account that liquid-cooled is more efficient. It can scale linearly and avoids hotspots and hidden costs. It helps to optimize rack density, increases the power utilization, and also boosts the performance, which air cooling somehow is not so efficient in doing. And let's not forget the rack density and the data space utilization. You get much higher density with liquid-cooled servers. And we at Supermicro, we also ran some simulations and tests and also looked at the actual deployments. We saw that the total cost of ownership was 80 million less in a period of 5 years when you're deploying versus air-cooled data centers deploying up to 8,000 GPUs.
Lieke, you want to add something?
Yeah, I think, and that's in a lot of discussion, I don't think it's just like black and white on air cooling versus liquid cooling. I think if we look at the world today and what AI workloads and high-performance compute and data-intensive workloads, they ask more GPU performance. And with more performance, more heat is coming our way as well. But if you look at the whole ecosystem, and we at Dell look at cooling more as a transformative technology. It's not the afterthought right now. It should be a design principle if we look at the whole ecosystem. And it's not only the chip cooling. It's an end-to-end strategy from chip to server to rack to data center. So it should be incorporated in your design. And if you look at the TCO, maybe the investment upfront is a little bit more. But afterwards, we see already in the IT, the AI infrastructure that we build and we sell, that we can put more density into a rack. So we have a 50+% more density in a rack. But we also see we can lower the energy cost at the same time with 11 to 18%. And that's because we are using direct liquid cooling with rear door heat exchangers. So it's all in the design on what do you want to obtain in the end, or what you want to do. And it's not only air or liquid, it will be a mix. Air will be still there. It's really targeting the right workloads, which do need liquid cooling. So most of the data centers still will have a big air cooling solution. Some of them will be a mix. The large hyperscalers, the large AI gigafactories will be fully liquid cooled probably. So there's something for everybody at once, but it should be a design principle from the start.
Yeah, I definitely agree. I think there will be a mix, and air cooling will have a future. Everybody will try to use it as long as they can, but if densities climb and climb, slowly there will be a transition. Mike?
Yeah, I just think the whole economic model of high-performance liquid-cooled data centers is very different. Clearly, the revenues that they can generate is different, and so then people obviously look at the operating cost and through a different lens. I think, CBRE's interest is in the day two operations of the data center for its life. We bring the people into the data center to do the mechanical and electrical services and the IT services. So, by bundling that together, as we do, you can obviously reduce that overall people cost. And we've probably got about 30 data centers liquid cooled today, so we're starting to learn. It's obviously still emerging and rapidly developing sort of industry, so we're still learning the right ways to operate them. But through the experiences that we've already had, we're starting to find ways to optimize and probably understand some of the design decisions that could help to reduce the total cost of ownership of some of those data centers. And some of the pipeline customers that we've got are gigawatt campuses that they're talking to us about. So we're trying to then operate at a considerably different scale than we've ever done before. So having those early conversations about where to have the NOC and how many to have and how to get the people to move around the site, because obviously the travel time becomes a lot, how to do the maintenance of the generators and the UPSs in a more economical way. So I think there's a lot that we're all going to learn about how to drive down the people and maintenance and operations costs of these data centers. So.
Right, and I assume all the 6 data centers are in the US?
No, a lot of the ones we've got today are in APAC. So that's probably some of the largest prevalence of liquid cooling today. So I had the opportunity to visit the sites in Malaysia and Australia where we're already doing this. When we've got several other countries in APAC going live, we've got some in Europe, and we're doing it obviously in the US as well. One of the biggest ones is the Aurora supercomputer, a 60 megawatt government computer. So that's a fascinating one to get involved in. And a lot of the conversations this morning have been about these swing loads that you see, and that one can go from 10 megawatts to 60 megawatts and back down again. So we're starting to really learn and understand, just on a small scale what that happens, let alone across the whole of Virginia going up and down. It's going to be quite impactful on the grid. So I work a bit with the IEEE on that, and I think the grid companies are very interested in talking to the data centers, and that's probably, so it seems to be happening in Europe a lot through the conversations that have happened this morning on the stage, and I think starting to happen in the US as well now. So,
absolutely, understood. So talking a little bit about thermal management, right? To what extent will thermal management put limits on rack densities, servers, and rack utilization? Do you think there are limits, Lieke, from your point of view, looking at?
If we look at where we're transitioning now, so I mean, when we're talking about AI, right? So we're transferring from 10, 20 kilowatts to 40, 50 kilowatts per rack. Our integrated rack solutions, even we build up to 400 kilowatt already, so we have to place that as well. I think we can do better. So if we look at all the solutions that we build right now, we deliver thermal measurement solutions with it. So it's really also on getting visibility in your current data center, what you already have, and how you are using your power. So it's not for more power, but to better power use. It's what we already see in the new latest and greatest infrastructure, that we can have a better TCO with more density per rack. But we can also really optimize what we already have and make the transition from the current state of the data center to the new version, or with liquid-cooled AI-ready racks in it. So I think it starts first with visibility, see what you can already improve with your telemetry. You can put AI operations, AI ops on top of it, so you have a better you can observe better, and you can see your performance and see how you can tweak. And I think that will be the way forward for better decision making in the future.
Understood. So you said going up to 400 kW per rack today already?
Yes.
Is that very common? Is that something very special? Is that a
not in the Netherlands
lighthouse project?
Not in the Netherlands, but we see it in Europe already, and we see it definitely in the US and the Arabic countries. Yeah.
Aditya, how do you see that? And with Supermicro as a
Yeah, so as Like said, we also see racks going all the way up to 400 kilowatts up to 0.5 megawatts. And we have also deployed some racks which are capacity of more than 0.5 megawatt. But the most common standard right now is rack in the range of 180 to 200 kilowatts. That's the most commonly used rack design as of now. And as you were talking about the density, as the industry evolves and as the liquid cooling and data centers are also evolving, it will start to become more about how many flops can I have per rack rather than the density. So that will be an interesting deciding factor of how to really manage the overall rack density and how to see we can get the best PUE and efficiency out of the entire infrastructure deployment.
Okay. And the discussion about these higher density racks, 500 kW per rack, is that still in a typical 48U rack, or is that special build racks?
So
looking at what
when we are going for higher power per rack, then the density is also increasing, so is the rack height. So we also see deployments where the rack can go anywhere from 50U to 60U in height. So it all depends on the customer requirement, their loading capacity, and their data center infrastructure planning. And we can really plan the deployments depending on those requirements.
So it's a lot of customization that more or less takes place.
Yes, it's a lot of customization we have to take into account because we're not talking about a couple of millions. These racks can go anywhere from 100 million and plus. So they are pretty expensive and costly deployments. And of course, there's a lot of customization which goes into it depending on what the customer really wants.
Understood. Mike, do you believe that liquid cooling will become the standard? And if so, how soon?
It's certainly starting to become the norm in a lot of the conversations we're having with our new customers. I don't think air cooling is going to go away anytime soon. We've got an awful lot of enterprise sites and co-location sites that are always going to have air. And all the sites that I visited have all still got a proportion of air alongside the liquid-cooled racks that they've got. So I think we're going to probably continue to see that. I do think that we're going to learn a lot more over the coming weeks and months about failure modes of liquid cooling and things like that. I think I've spent my whole life in reliability, risk management, and trying to design out failure modes, and there's a lot more failure modes in liquid cooling. So I think we've got a lot to learn on that basis that will be interesting, especially with the cost of some of the equipment. And I go in and I see all this chilled water pipe or liquid cooling water pipe, PG25 pipe over the top of it, and you think we've been spending years trying to get rid of that, and now it's all back in there. So I think it's gonna certainly continue to grow in the coming period, but we'll still have a lot of air cooling as well. I think a lot of people on the stage have said adaptability and flexibility, and that's been a theme of many of the conferences I've been to recently is, we need to design these data centers that could be all air or could be all liquid or could be, some percentage of both. So that's where I'm seeing it going.
Yeah, I saw your face already. What's your take on that?
I think what I always say, liquid is not becoming standard, it's becoming mainstream. It will be one of the choices that we have. And I think for me, it's everything has to do with optimization, like how are we using the air smarter and how are we using targeted liquid? So, when the silicon demands it or the business case demands it, you should go for the liquid part. But I think that's what I also mentioned. It's really up to the workload. And I think when I look back in the beginning of the cloud era, what we should have done back then, finding the right cloud, public, hybrid, private, for the right workload, it's the same right now with, what do you need for the AI workload or a more traditional workload. So you don't always need the AI compute for traditional compute stack or whatever. So it's really targeting, what is the business case, what is the demand, and what do I need for that?
Aditya, do you have anything to add to that?
Yes, definitely. As Like and Mike said, we won't see liquid cooling dominating air or air cooling dominating liquid. It will be basically liquid cooling will be the key enabler for the new technologies. Liquid cooling will be used more where you have the AI and HPC workloads, and all for general compute workloads, air cooling will still be dominant. So the future is not about liquid replacing air, but who will be able to adopt both these technologies efficiently and be able to utilize their efficiency and use case scenarios depending on their requirements and performance needed.
Understood. Speaking of liquid cooling and taking a look at how it's been deployed today, there is a lot of discussion about the fluid temperatures, right? I have to say, when liquid cooling started, I believe a lot of us thought that chillers or mechanical cooling will go away because we don't need the low water temperatures. So the opposite more or less happened, right? We're seeing temperatures being asked for 26 degrees, a typical standard, even so a chip could happily operate at 45 degrees. Do you think there is a trade-off, higher temperatures versus performance versus efficiency?
So I guess the news about the smashing the chiller last week made headlines and affected stock prices. I thought back to 2010 when I was at a data center dynamics conference and Don Beatty announced the higher ASHRAE bands and said, we're not going to need chillers in data centers anymore. I had a big chiller with a red cross through it. And that was 16 years ago, and we've still got, for the last 16 years, had lots of chillers in data centers because nobody really increased the temperatures in accordance with those new bands. So I think we're starting to see similar things with liquid cooling as well. And the other thing, I think, to build the flexibility, we're seeing a variety of different heat rejection methods, I guess. And a lot of sites are being built so that the primary facility water can do the cryo units and the liquid cooling as well, because we just said we're probably still going to need the air as well. So if you're building flexible sites that can have a system that can adapt to both, then that's going to obviously affect ultimately the water that you're actually cooling. Although I've been to other sites where they've got a dedicated cooling towers for the chilled water and then for the liquid cooling, and then air-cooled chillers for that. So there's a mixture of things going on out there, I think.
Right. I don't believe that chillers will go away, and air cooling will always remain. I think we're all in agreement there. But if you're looking at your servers, Lieke, if you have the choice to operate them with a 26-degree water or 45, are you looking at performance gains that you can have, or is it more a safety margin that you want to have there to ensure that if the flow is interrupted, your server is not being damaged?
I think the latest chips can get up to the 45 degree, but I think, and that's what we traditionally see also with our customers, is that we usually target on around the 25, 30 degrees with the safety margin ahead. I do think that with the software and the telemetry that we can higher it a little bit, but still within the safety margins. We don't want, I call it reckless racks. And we want to do it sustainable and safety. But we do have the benefit that if we use a higher water temperature, the benefit of the water going out for district heating and things like that, it's better. So if we want to look at more the sustainability in a broader ecosystem out of the data center, and we're looking at how can we reuse the water, then a higher temperature has more benefits outside. So I think if you observe and you see where you have the margins to maybe use a little bit of higher temperature, but that's all with data and analytics and AI to get the overview of your whole premises and see what are you using. I think we can grow together. We grow it into each other. So we have benefits inside and outside the data center.
So do you think there is a willingness to do that, to reduce the safety margins, to gain efficiency, to be more effective in waste heat reuse? Aditya, what do you think?
Yes, as you said, we also allow the inlet temperature to be in the range of 25 to 45 degrees. But the operators are going for lower inlet temperature. It's basically not because the equipment cannot handle it. it's because they want to mitigate the risk. So basically, this is a risk management feature. But as the technology evolves, as the telemetry improves, and as the technology advances even further, operators will be willing to go for a higher inlet temperature, and that will also improve the overall TCO and reduce the PUE of the data centers.
When you say technology evolves, what do you mean with that? What has to happen from a cooling perspective that you would say we can safely operate at higher temperatures?
So the safety margins have to improve. The operators have to get more confidence because though liquid cooling has been there for quite some years now, it's still in a very nascent stage. There's a lot of a niche market where you need to have specialized skills to be able to deploy large-scale liquid-cooled data centers. It also carries higher risk. So to mitigate all those things, it has to be a little bit more mature technology so that the operators can run on them confidently.
Mike, you wanted to add something.
Well, I was just going to say, I think one of the reasons we didn't see air-cooled data centers getting warmer is because obviously chip failure rates increase as you get hotter, and it's all a trade-off between, how many are you going to allow to fail. And I'm sure that must apply, I'm not a chip expert, but I'm sure that must apply to liquid-cooled chips, that the warmer they run, maybe the failure rates are going to change, and there's probably going to be a lot that we learn. And as we said earlier, these are much more expensive chips to fail than the old air-cooled chips. So I think there's going to be a factor of that, and we'll learn how tolerant they are to higher temperatures, I guess, over time, because it's not just today, it's going to be for 3 years or whatever that chip's got to operate for.
Absolutely, but again, it's all about, I hear a lot now, more mature technology. Which technology has to become more mature from your point of view? Is it the chip that the chip maker says you need lesser margin of error? Because they made the statement. If we take a look at NVIDIA, there was a very clear statement, the next generation can operate at 45 degrees. I have a lot of question marks there because the density of that new chip is even much higher than the current one. And so technical challenges. So it has to be a give and take, right? Because we also talk a lot about sustainability, and it's one of the hot topics. We want to reuse the heat. We want to make sure that we minimize waste. Something has to give, right? And you mentioned it already. If we would allow higher operating temperatures, we would see maybe new opportunities to do more than just district heating. So from a server manufacturer, what has to happen? For example, what would be you ask for a company that provides the cooling?
I think, cooling is not there just, to protect servers from overheating. What I already said, cooling need to be a design principle up front. So cooling is becoming the more important technology because we know the roadmap for the GPUs. We already know it for like the 2-3 years ahead. So, the power and cooling roadmap should follow that one. So on that part, and, as we look at it, as I already mentioned, for us it's an end-to-end strategy. So we can do things on the chip server part, smarter airflows, things like that. We can do it on the rack part, the rear door heat exchanger. We can do it on the data center part. And on top of all of this, using a power manager software or our iDRACs or things like that, you get an overview on what you can do. And sustainability and density can move together. They're not enemies. So we already saw that, having more density in a rack with proper cooling solutions, we can bring the power of cooling and energy down. So, and it depends on the case and the workload and how the whole data center is operated, but we can look at it case by case, how we can move forward on this one. So it's, I think probably, going forward, we need each other more and more in the ecosystem. It's not only the data center builders or the operators or the chip makers or we as the infrastructure builders, or it's also what's landing on top. So I think it was said already in the previous panel, we need to find each other more and more in the design, in speaking to each other on how we are going to move forward in this new world of AI, because this is really a new world for all of us. And it's asking a lot from the infrastructure part, it's asking a lot from the chip part, but it's also asking a lot for the data center design of the future and how we are going to help the brownfield data centers that we have to move slowly into that era.
Yeah, I couldn't agree more. Getting closer together and ensuring that we all work together and make sure not having islands of design that then somehow are being connected, as it was the case until now, is definitely something that we all should look at. The question is how much willingness is there and the competitiveness that we have in this market. These are all factors, I believe, that we need to also take a very close look and maybe push them aside and say it makes more sense doing stuff together. You mentioned a lot rear door heat exchangers as a solution, and I'm hearing this also quite often. Aditya, what is your take on that? You said it also.
I think the rear door heat exchanger is a great solution. As we're talking about the ecosystem, the whole ecosystem is evolving. Direct-to-chip cooling is the dominant cooling standard in the industry. A few years ago, we were seeing direct-to-chip having efficiency of 85%. So by 85%, I mean 85% of the heat is removed by liquid in the system. But now we are seeing direct-to-chip being able to remove 98% of the heat from the system. And now people are talking, how about the rest of the 2%? Can we have 100% liquid-cooled data center without the need of any additional air cooling or HVAC equipment for the data center? And that is possible when we have the rear door heat exchanger. The rest of the 2% of the heat is effectively removed by the rear door heat exchanger, giving us a 100% liquid-cooled data center, again, improving the overall efficiency and TCO and reducing the PUE to less than 1.
But you still have an air-to-air heat exchange taking place.
The rear door heat exchanger is also based on liquid. So everything is run on liquid, and you don't have to maintain any special environment inside the data center. So that's the whole idea of having the rear door heat exchanger in our deployments.
Rear door heat exchangers and maintenance. Mike, how do you see that?
Yeah, I think we've had rear door heat exchangers for quite a long time. So we've had some good experience of doing that. I think, again, slightly different maintenance techniques, but we've managed that and we've eliminated single points of failure and understand failure modes there. But I think, again, creativity is coming in and we're seeing other solutions, lots of in-row cooling instead of rear door. That's starting to become more prevalent in some of the sites I've been to, or just putting some cooling on top of the whole row to make it completely self-contained and doing it that way. So we're seeing various different ways, rear door, definitely we're running one of the largest sites in Portugal, which is predominantly rear door cooled at the moment. So that's something we've been doing, but I think we'll see other techniques for getting the piece that the water can't get out of the direct-to-chip out in other ways as well. So.
Okay, but to me, it's always configurations done in a little bit different way, right? So there's I think, agreement that there will always be a need for a little bit of air cooling, one way or the other. There could be a rear door heat exchanger, could be an in-row unit, it could be a regular fan wall system, whatever it is. But I think it will remain a combination. But what do you think is happening if the densities go farther up? As we all know, they will. We will talk about densities, a kilowatt per GPU, something like that. Do you believe that what we're seeing today, meaning going with a single-phase approach, PG25 on the liquid, is the future? Or do you think that we need to come up with something new? Leke?
So right now we're looking at more like the direct liquid cooled approach. But of course in the industry, in the market, they're already looking at two-phase cooling, gas cooling. We're not there yet. That's ahead of us. But I think where we are right now, And if you look at what we're doing, or the workload placements, I think it's country dependent. If I look at the Netherlands, we are a small and mid-sized country, organization-wide. Do we need it? I don't know. It will be a mix. We at the moment, a lot of organizations are still in the pilot phase. To be honest, the Netherlands is a very public cloud-minded country. A lot of the infrastructure or platforms went to the public cloud. We see a lot of organizations coming back because of the cost of AI and data movement and data gravity. So there's also like a cloud repatriation journey going on for a lot of customers. And then it depends on, for what workloads do you really want to use AI, or is it more analytics? Or I think we're also figuring out as a society on what is AI and how are we going to use it. It's really depends on what you want to achieve and what you need for it. So, of course, I have customers who already bought like a GPU, and I'm like, okay, maybe you did buy a Rolls Royce, and maybe a Volvo is enough for you. I think there's still also a lot of unawareness in the market on what do you really need, or is it kind of like a FOMO?
Yeah, I mean, developments are very fast right now, right? In 10 years ago, there was a design and that was utilized for a number of years. Now we can be happy if something lasts a year before somebody comes up with something new or increases density or whatever it is. Aditya, what is your take on that, on going to the next level?
So the next level is basically, it's not that liquid cooling or air cooling will be competing with each other. They're both complementary technologies. The future won't be liquid cooling replacing air cooling, but it's a response to a different kind of needs and requirements of the industry, depending on the cooling and performance. It will be basically dependent on who is able to integrate both and utilize both more efficiently, depending on the workloads, requirements, and the performance of the systems and their workloads.
Okay. Going back a little bit to the discussion we had about heat reuse, right? Mike, you as somebody that operates data center, maintains data center, what do you think alternatives could look like to have a more effective way of heat reuse? As we said earlier, there's not always district heating available, and we have summer and winter time, and a data center consistently produces waste heat, more or less. Do you think that there are alternatives out there that could be applied?
I think obviously it depends on the location. If you're in a metropolitan area where you can reuse the heat in an industry or a school or a swimming pool or offices such like, then that helps. A lot of the data centers are in very remote places where that isn't possible. It was interesting, somebody on the stage previously talked about the geothermal solution of pushing the heat down and storing it, and I saw that at a conference last year, so I'm interested to see if that has got a future. It's possible that might be one of the answers, that we could start doing that, but I think there's going to be some more research into that, I'm sure. So that's where I'm at the moment. So.
Okay. Lieke, do you have something to add from your point of view, what could be done in order to be more efficient? Or is that not really?
Well, on a pragmatic level, I think, and I don't know in how much that has been done, but this is really about, getting visibility of what you already have. And, this is really on your power and your thermal behavior in your data center. I think there are areas to improve because we haven't done it before. The second part is optimize what you already have. It can be smarter airflows, it can be power capping, it can be smarter workload placement, things we already do. And then for the next part, if you're already looking at maybe power restraints, especially in the Netherlands, in some area we really have power restraints already, plan for an incremental adoption. So if you know what you have, if you already optimized what you have, then you can plan for a more high-efficient liquid-cooled solution, which could be integrated rack services or a rear-door heat exchanger, or the add-ons that keeps you moving into the future. But we can start now.
I think that was a great finish. So we have a few seconds left. Mike, do you have a message that you would like to bring across?
No, I think just be flexible and be open to change, because I think we're definitely in a period where we're all learning, and I think the collaboration idea is a fantastic one. We get the opportunity to talk to lots of customers around the world, so I think that's going to be a success key to everyone's success in the future.
Great, thank you. Aditya, quick one.
Just to finish it, the future is not about air versus liquid. It's about who can utilize the compute power and performance most efficiently.
All right, great statement. Thank you very much.
Thank you.
No, it was a pleasure.
Thank you.